In this module, we will look at the ice and rain protection system. First, we will start out with a description of the system. Next, we will look at individual components of the system. After that, we will look at the controls and indicators that were not covered during the system description. Finally, we will look at the aircraft performance monitoring, or APM system. The ice and rain protection system provides the aircraft with an all-weather capability, and consists of a de-icing system, an anti-icing system, and a pair of windshield wipers. The aircraft ice protection system uses both pneumatic air and electric heat. Pneumatic air provides ice protection of the outer, center, and inner wing leading edges, the horizontal stabilizer leading edges, the engine air intakes, and the engine gas paths. These sections of the aircraft use pneumatic boots which are inflated, in order to break up the ice. There are two types of boots. The first type of boot is a cordwise boot. This type of boot is used on the leading edges and the gas paths of the engine anti-ice system. The second type of boot is the annular boot. It is used for the engine intakes. The annular boot consists of circular tubes which inflate at the engine inlets. Ice is removed by inflating the boot. This slightly changes the shape of the boot, which results in the breaking and separation of the ice. Each boot actually consists of two boots, each with its own air supply. One boot is called boot A, and the other is called boot B. Both chambers alternate their inflation times, in order to better separate the ice. When a boot is deflated, it is held to the structure by a Venturi effect. The Venturi effect is created by the bleed air. The operating principle of the boot system is to inflate the boots in sequence. The inflation of the boots is controlled by the associated distribution valve. Seven distribution valves control the air supply to the associated boots. One distribution valve for each engine intake and gas path. One for the left outboard wing leading edge. One for the right outboard wing leading edge. One for the left center and inner leading edges. One for the right center and inner leading edges. And one for the horizontal stabilizer leading edge. Electrical power heats the propeller blades, the windshields, probes, static ports, and flight control horns. Two windshield wipers are used to remove rain from the two forward windshields. The controls for the windshield wipers are located on the overhead panel. The controls and indicators for the ice and rain protection system are located on the overhead panel and the flight instrument panel. The anti-icing panel and probes heating and windshield heating panels are located on the overhead. There is an icing AOA push button on the center instrument panel. In addition, icing information is displayed in the top portion of the primary flight display or PFD, as well as the memo section of the multifunction display, or MFD. The de-icing panel has schematic lines that mimic the general layout of the pneumatic portion of the ice protection system. We will now look at the individual components of the ice and rain protection system. We will start out with the ice detection system. The anti-icing advisory system, or AAS, consists of two probes and several indications. An icing evidence probe is located outside and below the captain's left side window. This probe is visible to both pilots and provides a visual indication of ice accretion. The probe is shaped like an airfoil and incorporates span-wise ridges to increase its ice accretion efficiency. This probe is not heated. The probe is designed to retain ice until sublimation or melting has occurred, and is intended to provide the flight crew with a visual means of determining that other portions of the airframe are either accreting ice or are free of ice. The icing evidence probe can be illuminated so that it is visible at night. The light is controlled by the navigation light switch. An ice detector probe is mounted on the underside of the left wing leading edge, between the pneumatic boots. This probe is powered by AC Wild Bus 2. The anti-icing advisory system provides the flight crew with a visual and oral alert when ice is accreting on the ice detector probe. When ice accumulates on the probe, an amber icing label is displayed in the flight mode annunciator, or FMA portion of the PFD. This label may be steady or flashing, depending on the status of the horn anti-icing and airframe de-icing push buttons. In addition, a single chime will sound, and the master caution lights will flash. The amber icing caption will illuminate when 0.5 millimeters of ice have accumulated on the probe. At that point, the probe will initiate a heat cycle to remove the accretion, and then start the ice detection process again. If the icing caption disappears, it indicates that ice is no longer accumulating. However, flight crews should note that the absence of the icing caption does not mean that the airframe is clear of residual ice. Note: the detection system may not reliably detect large supercooled drops that are near freezing, since there may not be enough heat transfer to freeze the large water drops that contact the probe. This would typically occur with freezing drizzle or freezing rain. The engine and airframe anti-ice system uses a combination of pneumatic air and AC electrical power. Pneumatic air is tapped before the high-pressure bleed valve, and flows through a pressure-regulating and shut-off valve called the de-ice valve. There is a de-ice valve on both the left and right side of the aircraft. You should note that due to the plumbing of the pneumatic system, the high-pressure port always provides the air for the system. This air is available, regardless of the position of the associated engine bleed air valve. Low-pressure port air cannot be used for de-icing. The de-ice valves are opened by selecting the airframe air bleed push button to the on position. In addition, each de-ice valve can also be opened, regardless of the airframe air bleed push button position, by selecting either of the engine push buttons to the on position. The de-ice valves modulate open or closed, so as to maintain a constant delivery pressure of 20.3 psi. The position of the engine bleed valves does not affect availability of air for the de-ice valves to operate. After the de-ice valves, the pneumatic air travels up to the engine dual distribution valves. These valves are electrically controlled and pneumatically operated. The engine dual distribution valve splits the air supply in two. Each line then feeds air to the air inlet de-icing boot and the gas path de-icing boot. This last de-icing boot is also known as the throat boot. The gas path system utilizes the inertia of ice contaminants along with an S-shaped duct. This design permits air to flow around the corner of the separator into the engine, whereas the heavier ice particles are ejected overboard. Shut-off valves, downstream of the engine dual distribution valves, prevent pneumatic air from going into the wing de-ice system, in case of a leak downstream. These valves are also called isolation valves. The isolation valves connect the pneumatic bleed supply from each engine to a common manifold. In turn, this common manifold supplies pneumatic air to the boots for the airframe de-icing system. This arrangement allows the system to remain operative in the event one engine has failed. The isolation valves are powered by the DC essential bus. The isolation valves will open when the airframe air bleed push button on the de-icing panel is selected on. Since these valves are pneumatically operated, they will open only if pneumatic air is available. As mentioned previously, selecting the airframe air bleed push button to on will also open both de-ice valves. The common manifold distributes air to the wing and horizontal stabilizer distribution valves. The wing and stabilizer de-icing system is controlled by the airframe push button. The system is selected on when the push button is pressed in. This sends a signal to the multifunction computer, or MFC, to initiate a de-icing cycle. The de-icing cycle is selected by the Mode Select Auto push button. Press the airframe push button to continue. When the Mode Select Auto push button is released out, the de-icing system is operating in the automatic mode. The cycle selection is determined by the two air data computers, and both multifunction computers. The Mode Select Auto push button is normally in the released out position. A cyan airframe message is displayed in the de-icing area of the memo section of the MFD, when the airframe de-icing system is selected on. At the start of the cycle, boots A in both engine intake will inflate. The boots are controlled by the associated multifunction computer. At the end of 5 seconds, these boots deflate. Next, boots B in both engines inflate, and remain inflated for 5 seconds. Once again, the boots are controlled by the multifunction computers. After this 5-second period, boots B in both engines deflate. Next, boots A in the outer portion of the wings inflate, and remain inflated for 5 seconds. During this period, boots B are deflated. MFC1 controls boots A. After 5 seconds, boots A deflate. Next, boots B in the outer portions of the wing inflate, and remain inflated for 5 seconds. Boots A are deflated. MFC2 controls boots B. At the end of the 5-second period, both boots B and the outer portions of the wing deflate. Next, MFC1 then commands boots A in the center and inner portion of the wing to inflate, and remain inflated for 5 seconds. Both boots B and the inner portion of the wing are deflated. At the end of 5 seconds, both boots A deflate. Next, MFC2 commands boots B in the center and inner portion of the wing to inflate, and remain inflated for 5 seconds. Both boots A and the inner portion of the wing are deflated. At the end of 5 seconds, both boots B deflate. Finally, the boots in the horizontal stabilizer are inflated. MFC1 commands boots A to inflate. They will remain inflated for 5 seconds. During this time, boots B are deflated. At the end of 5 seconds, both boots A and the horizontal stabilizer deflate. Finally, MFC2 commands boots B to inflate, and remain inflated for 5 seconds. During this time, boots A are deflated. At the end of 5 seconds, both boots B and the horizontal stabilizer deflate. So far, 40 seconds have elapsed. After the last set of boots have inflated and deflated on the horizontal stabilizer, the system will pause for a certain period of time before repeating the cycle. When the Mode Select Auto push button is in the auto position, the boots will be inflated and deflated in a 60 or 180-second cycle, depending on the temperature. If the static air temperature is greater than -20 degrees Celsius, the de-ice cycle is set at 60 seconds. If the static air temperature is less than -20 degrees Celsius, the de-ice cycle is set at 180 seconds. If the de-ice cycle is 60 seconds, the system will dwell for 20 seconds. If the de-ice cycle is 180 seconds, the system will dwell for 140 seconds. During this dwell period, none of the boots will be inflated. At the end of this dwell period, the boot inflation cycle will be repeated. The whole cycle length can be increased by means of the SAT less than -20 degrees Celsius push button. This push button is enabled by placing the Mode Select Auto push button in the depressed position. This will illuminate the manual caption in the push button. Notice how the arrow on the control panel points down to the SAT less than -20 degrees Celsius push button. Press the Mode Select Auto push button to continue. The SAT less than -20 degrees Celsius push button can be pressed in. This causes the slow caption in the push button to illuminate, and the cycle is forced to 180 seconds. If this push button is released out, the cycle is set at 60 seconds. The engine air intake and gas paths can be de-iced independently of the airframe. Engine de-ice can be selected by pressing in the engine push buttons. This automatically opens the associated de-ice valve, regardless of the position of the airframe air bleed push button, and sends a signal to the multifunction computers to initiate a de-ice cycle. The cycle is the same as previously described, except that only the engine boots are operated. The blue on light illuminates in an engine push button when it is pressed in. So far, we have discussed the de-icing system. De-icing is the process of removing ice. Anti-icing is the process of preventing ice from forming in the first place. On the aircraft, the propellers and flight control horns are electrically anti-iced. In addition, the probes and windshields are also electrically anti-iced. We will start out with the anti-icing of the flight control horns. The horns of the ailerons, elevators, and rudder are electrically heated using AC wild electrical power. The left elevator and rudder horns receive 115 volts AC from AC wild bus 1. The right elevator and aileron horns receive power from AC wild bus 2. The horn anti-icing system is controlled by the anti-icing panel, located on the overhead panel. The control panel is powered by the DC emergency bus. Horn anti-icing is controlled by the 2 push buttons. Each push button is labeled so as to indicate which horns are heated. Electrical power is supplied to the associated horn heaters when a push button is depressed in. When a push button is depressed in, the blue on caption illuminates, and a cyan horn label is displayed in the memo section of the MFD. It should be noted that horn anti-icing is inhibited when the aircraft is on the ground. When any horn anti-icing push button is selected on, the caption in the icing AOA push button, located on the flight instruments panel, illuminates green. This is due to the fact that the stall warning AOA threshold has been automatically lowered by the selection of horn anti-icing. The green caption serves as a reminder to the crew that the stall warning AOA threshold is now lower. In addition, a green icing AOA label is displayed in the left-hand side of the FMA. The icing AOA light also serves as a reminder for the crew to set the speed bugs and observe minimum icing speeds. The green icing AOA light can only be extinguished manually by depressing the push button after both horn anti-icing buttons have been selected off. This should only be done after the crew has confirmed that the aircraft is clear of ice. By deselecting horn anti-icing, the stall warning AOA threshold is reset to the values defined for flight in normal conditions. The inner leading edges of the propellers are electrically anti-iced. The heat decreases the adhesion strength of the accreted ice, which then causes ice built up on the propellers to shed by centrifugal effect. Propeller heat is powered by the respective AC wild bus. Heat is supplied by resistors mounted near the surface of the inboard section of the blade leading edges. The heating elements on every other blade on a propeller are electrically connected. Propeller anti-ice is controlled by the two prop push buttons located on the anti-icing panel. When a push button is pressed in, the on caption illuminates blue. Electrical power is applied to the propeller heaters on the associated propeller, and a cyan prop message is displayed in the memo section of the MFD. When propeller heat is selected, the propellers will be heated using a cycle similar to the airframe boot inflation cycle. The heating cycle is selected by the mode select SAT less than -10 degrees Celsius push button, also located on the anti-icing panel. When propeller anti-ice is selected on, blades 1, 3, and 5 on propeller 1 are heated for 10 seconds. After 10 seconds, heat is removed from these blades, and heat is applied to blades 2, 4, and 6 on propeller 1. Heat is applied for 10 seconds. After 10 seconds have elapsed, heat is removed from blades 2, 4, and 6 on propeller 1, and heat is applied to blades 1, 3, and 5 of propeller 2. After 10 seconds, heat is removed from these blades, and heat is applied to blades 2, 4, and 6 on propeller 2. Heat is applied for 10 seconds. At the end of the 10-second period, heat is removed, and none of the propeller blades are heated. The complete heating cycle will be repeated after a 10-second period. This cycle is called the low power cycle, and is used when the temperature is greater than -10 degrees Celsius. The propeller heating cycle can be manually controlled by the mode select SAT less than -10 degrees Celsius push button on the anti-icing panel. This push button manually controls the propeller anti-icing cycle when the mode select auto push button on the de-icing panel is in the manual or pressed in position. When the mode select SAT less than -10 degrees Celsius push button is in the normal released out position, the low power cycle is selected for the propeller anti-icing. When the push button is pressed in, the propellers will be heated using the high power cycle, and the on caption in the push button illuminates blue. The high-power cycle heats the propeller blades in the same sequence, except that the heating time is 20 seconds, and there is no pause between cycles. The high-power cycle is used when the temperature is between -10 and -30 degrees Celsius. Supercooled water is non-existent below -30 degrees Celsius, so there are no propeller icing problems below that temperature. The two front windshields are heated to provide anti-icing and defogging. The side windows are heated, so as to prevent fogging only. The forward windshields are heated by an electrically heated transparent film that is sandwiched between the two plies of glass. Each windshield heat is powered by the associated AC wild bus. A temperature controller maintains the temperature of the outside ply above 2 degrees Celsius. The controller maintains the inner ply above 21 degrees Celsius to prevent fogging. There are two temperature controllers, one for each window. The side windows are heated by the associated 28-volt DC bus. The heating system consists of small wires embedded between the two plies of glass. The side window temperature is regulated so as to maintain the inner temperature above 21 degrees Celsius. Window heat is controlled by the windshield heating control panel, located on the overhead panel. Two push buttons control the heating of the two forward windshields, and the side windows push button below controls the heating of the side windows. When a windshield push button is pressed in, the associated windshield heat is supplied AC power. Forward windshield heat is deactivated by releasing out the associated windshield heating push button. When the push button is released out, the white off caption illuminates in the push button. The fault light illuminates in the event there is a loss of power to the associated window heat system. The other indications of a windshield heat failure consist of the master caution lights flashing, a single chime sounds, and an amber anti-icing windshield message is displayed on the EWD. The affected window is identified by the letter L or R. The fault light also illuminates during an MFC test. The side windows push button controls the heating of both side windows. Side window heat is activated when this push button is pressed in. When selected, the blue on caption illuminates in the push button, and the cyan side windows message is displayed in the memo section of the MFD. Side window heat is deselected by releasing out the push button. The fault light illuminates in the event of a loss of power to the side window heating system. In this situation, both master caution lights flash. A single chime sounds. An amber anti-icing window message is displayed on the EWD. And an amber side windows message is displayed in the memo section of the MFD. AC power is used to electrically heat the captains, first officers, and the standby pitot tubes, the captains and first officers' alpha probes, and the total air temperature, or TAT probes. All probes are heated by the associated AC wild bus, except for the standby pitot tube and the four static ports. The standby pitot tube is heated by AC wild bus 1 and the AC standby bus. The captain's and standby static ports are heated by DC bus 1, whereas the first officer's static port heat is powered by DC bus 2. Probe heat is controlled by the probe's heating control panel, located on the overhead panel. The captain, standby, and first officer push buttons control the heat to the associated probes. Probe heating is activated when a push button is pressed in. Probe heat is deactivated by releasing out the associated push button. When released out, the off caption illuminates white in the push button, and the associated probe heat lights above illuminate amber. Static port heat is controlled by the associated probe heat push button. For example, the captain probe heat button activates the captain's static port heating. Fault lights monitor the heating of the associated probes. These lights are located above the probe heat push buttons. When a probe is not heated, the associated light will illuminate amber, a single chime will sound, the master caution lights will flash, and an amber anti-icing probe message is displayed on the EWD. An additional amber message will identify the affected probe. This alert will occur if there is a fault in the associated heater, or if the system is turned off. The control panel displayed here is interactive, and you can turn the probe heat on or off. Lights monitor the heating of the associated probes. These lights are located above the probe heat push buttons. When a probe is not heated, the associated light will illuminate amber, a single chime will sound, the master caution lights will flash, and an amber anti-icing probe message is displayed on the EWD. An additional amber message will identify the affected probe. This alert will occur if there is a fault in the associated heater, or if the system is turned off. The control panel displayed here is interactive, and you can turn the probe heat on or off. It should be noted that the TAT probe heat is automatically inhibited when the aircraft is on the ground, and the condition of the probe is not monitored when the aircraft is on the ground. In addition, the flight warning system does not monitor the condition of static port heat when the aircraft is in flight. 2 windshield wipers remove rain from the 2 forward windshields. Each wiper is driven by a 2-speed DC electrical motor. The captain's windshield wiper is powered by the DC Essential bus, and the first officer's windshield wiper motor is powered by DC bus 2. Each windshield wiper is controlled by an associated rotary selector that has 3 positions: off, slow, and fast. These selectors are located on either side of the overhead control panel. When off is selected, the wiper automatically parks. The fast and slow positions control the speed of the associated wiper. Fast will cause the associated windshield wiper to cycle 130 times per minute, whereas the slow position will result in 80 times per minute. It should be noted that there is a speed limit associated with the use of the windshield wipers. Windshield wipers should not be used when the airspeed is above 160 knots. We will now cover some of the controls and indicators. The icing AOA push button is located on the captain's side of the flight instruments panel. As discussed earlier, the amber icing label appears on the FMA when ice accretion is detected by the Anti-Icing Advisory System or AAS. The icing label is steady if accretion is detected, and both horn anti-icing and airframe de-icing are selected on. If either horn anti-icing or airframe de-icing is selected off, the icing label will flash. In the event of an AAS detector fault or a loss of power to the system, both master caution lights flash. A single chime sounds. and an amber anti-icing detect message is displayed on the EWD. The caption illuminates green in the icing AOA push button, when at least one horn anti-icing push button is selected on. The purpose of this illuminated caption is to remind the crew that the stall alarm threshold has been lowered. The caption can be extinguished by pressing the icing AOA push button, but only if both horn anti-ice push buttons are selected off. The control panel on this screen is interactive, so you can extinguish the icing AOA caption. In the event, the caption illuminates green in the icing AOA push button, when at least one horn anti-icing push button is selected on. The purpose of this illuminated caption is to remind the crew that the stall alarm threshold has been lowered. The caption can be extinguished by pressing the icing AOA push button, but only if both horn anti-ice push buttons are selected off. The control panel on this screen is interactive, so you can extinguish the icing AOA caption. The ice detection system can be tested by means of the test button, located under the icing AOA push button. The button should be pressed and held for 3 seconds. During the test, the amber icing label flashes on the FMA, a single chime will sound, and both master caution lights flash. If a fault is detected during this test, an amber anti-icing detect alert is displayed in the EWD. In addition, both master caution lights flash and a single chime sounds. A cyan message is displayed in the de-icing part of the memo section on the MFD, when the de-icing system is selected to on. This airframe message will flash if the airframe de-icing system is still on, 5 minutes after the last detection of ice accretion. The message is displayed in amber, in the event of a failure of the de-icing system. As discussed earlier in this module, the engine push buttons control the de-ice valves, as well as the 2 outputs of the associated engine distribution valve. When an engine push button is pressed in, the de-ice valve opens, even if the airframe air bleed push button is released to the off position. In addition, The MFC is signaled to initiate a de-ice cycle, the cyan on caption illuminates, and a cyan engine message is displayed in the de-icing part of the memo section of the MFD. When the engine push button is released out, the on caption extinguishes, and the associated de-ice valve closes. The fault light illuminates when the associated distribution valve is commanded open, but there is no or low bleed air pressure downstream of the valve, when the associated distribution valve is commanded closed, but pressure still exists downstream of the valve, when the airframe air bleed push button is selected off, and the temperature of the bleed air upstream of the de-ice valve exceeds 230 degrees Celsius, or in the event of an incorrect inflation sequence of boots A and B. The airframe air bleed push button controls the operation of the de-ice valves and the isolation valves. When the push button is selected in, the de-ice and isolation valves will open. When the push button is released out, the de-ice and isolation valves will close, and the off caption illuminates. However, engine de-icing can still be accomplished by selecting the engine de-ice push buttons to on, since this will open the associated de-ice valve regardless of the position of the airframe air bleed push button. It should be noted that the airframe de-icing will not be available if the airframe air bleed push button is selected off. The fall caption illuminates amber and the FWS is activated when the air pressure downstream of the de-ice valves is below 14 psi for more than 10 seconds, or when the air temperature of the bleed air upstream of the de-ice valves exceeds 230 degrees Celsius. The fall caption is extinguished when the airframe air bleed push button is selected out. If the fall caption illuminates, both master caution lights will flash, a single chime will sound, and the amber anti-icing bleed message is displayed on the EWD. The airframe push button controls the inflation of the A and B boots, via the wing and horizontal stabilizer dual distribution valves. Pressing the push button in will signal the MFC to initiate a de-icing cycle, and the on caption illuminates blue. The boots are deflated when the airframe push button is released out. This is the normal position of this push button. The fall caption illuminates amber and the flight warning system, or FWS, is activated when a distribution valve is commanded closed, but bleed air pressure still exists downstream of the valve, or if a distribution valve is commanded open, but no pressure is sensed downstream of the valve. The alert consists of both master caution lights flash. A single chime sounds. An amber anti-icing frame message is displayed on the EWD. And an amber airframe message is displayed in the de-ice part of the memo section of the MFD. As discussed earlier, the Mode Select Auto push button controls the operation of the de-icing system. When the push button is released out, the system is operating automatically, and the SAT less than -20 degrees Celsius push button is inoperative. The released out position is the normal position for the Mode Select Auto push button. The fall caption illuminates amber when there is a failure of either MFC 1B or 2B, or if there is an air data computer, core processing module, or input-output module failure. The SAT less than -20 degrees Celsius push button is disabled when the fall caption illuminates. The de-icing system incorporates an emergency mode of operation. This mode is selected by the guarded de-icing override push button. The emergency de-ice mode is activated by lifting the guard and pressing the push button. This sets a timing cycle of 60 seconds, the override caption illuminates blue, and all the de-icing lights extinguish. The emergency mode is used when a fall caption illuminates. The fault light in the de-icing override push button will illuminate amber if there is a failure of both MFC modules associated with boot inflation, which would result in an incorrect inflation sequence. Additional indications of this condition consist of both master caution lights flashing, a single chime, and the amber anti-icing select message on the EWD. Horn anti-ice is controlled by the horn anti-ice push buttons. When a push button is pressed in, the associated horns will be electrically heated. Releasing a push button out will deactivate the heating of the associated horns. When any horn anti-ice is selected, the stall threshold is automatically lowered. The fault light illuminates amber and the flight warning system is activated when one of the horn heaters is not powered when it should be. Propeller heat is selected by the prop push buttons. When a push button is pressed in, the associated propeller blades are heated. Releasing the push button out deactivates propeller heat. The fault light illuminates when the heating elements in one blade in the associated propeller is not powered. If this happens, a single chime will sound, both master caution lights will flash, and the amber anti-icing prop message is displayed on the EWD. The Aircraft Performance Monitoring System, or APM, monitors aircraft drag while in icing conditions. The system also monitors aircraft cruise speed, and it will check that the minimum severe icing speed, or MSIS, is respected when warranted. The APM is activated when the airframe de-icing is selected on. The icing AOA light is illuminated. Ice accretion is detected. The static air temperature is below 10 degrees Celsius. Both engines are operating. And the flaps and gear are retracted. The APM will compare the actual drag with the theoretical drag. This theoretical drag is based on the weight of the aircraft. This weight is derived from the Flight Management System, or FMS. If the FMS does not supply this value, the APM will use an estimated weight. The system will provide a degraded performance caution when there is an abnormal drag increase that could be due to severe icing conditions. The indications of this situation consist of an amber degraded performance message on the FMA, both master caution lights flashing, a single chime, and an amber degraded performance message on the EWD. The APM will generate an increased speed caution when the aircraft's speed is lower than the minimum severe icing speed plus 2 knots. The indications of this situation consist of an amber increased speed message on the FMA, both master caution lights flashing, a single chime, and an amber increased speed message on the EWD. The system will generate a cruise speed low caution when the aircraft is in the cruise mode. The airspeed is 10 knots less than the maximum cruise speed, and there is a small drag increase. The indications of this alert consist of a cyan cruise speed low message on the FMA. The APM is controlled by the APM push button, located on the left side of the flight instruments panel. The system is disabled by releasing the push button out. This will be indicated by the illumination of the off caption. The fault caption illuminates amber in the event a fault has been detected in the system. This fault could be due to an internal failure or invalid aircraft parameters. Additional indications of this fault consist of both master caution lights flashing, a single chime, and the amber APM fault message displayed on the EWD. Since the APM is only active while the aircraft is in flight, the fault detection is inhibited when the aircraft is on the ground. The system should be tested daily by pressing the test push button below the APM push button. This concludes the ice and rain protection module.